Welcome to example number 1, expanding a binomial expression using negative powers. Suppose we want to expand the fraction 1 over p minus q. How would we go about it? Step number 1, we are going to apply the laws of indices to rewrite the fraction. Remember, the binomial expression is this, which is on the denominator. And we want to apply laws of indices so that we can write the binomial expression as a numerator. So firstly, we know that according to laws of indices, any expression can be raised to the power 1. So I've raised this expression to the power 1. Then I'll further apply the laws of indices to rewrite this as p minus q raised to the power minus 1, because that can be written as its reciprocal raised to a positive number. Okay, so after we've done that, we will recall the binomial theorem. The binomial theorem states this. We have looked at many binomial theorems by now, and this time I won't go through it. And please make sure that you have watched the earlier videos to understand the binomial theorem. Then step number 3, all that we're going to do is compare p minus q raised to the power negative 1 to a plus b raised to the power n. So here what we see is that where there's a here, there is p, so a is equal to p in comparing. And where we've got a b here, we've got a minus q. Notice that we consider the negative. If there's a negative, we consider the negative sign as well. So our b is going to be equal to negative q. And n, of course, is equal to minus 1. Okay, then we're going to substitute now all those values into the binomial theorem. And if we do, this is what we're going to have. We're going to have that p minus q raised to the power negative 1 is going to be equal to p. Okay, so where there's a there, we've substituted p. Where there's b, we substituted negative q. And where there's n, we substituted negative 1. Okay, so here we're going to have p raised to the power negative 1. So p raised to the power negative 1. Our n is negative 1, so we're going to have negative 1 there. Our a is p, so we're going to have p. N is negative 1, so negative 1, negative 1. Our b is negative q, so we're going to have negative q raised to the power 1. Okay, and so on and so forth. So we have negative 1, negative 1, negative 1 over 2 factorial, p, negative 1, negative 2. Then our b is negative q raised to the power 2. Okay, so we're going to have negative 1, negative 1, negative 1, negative 1, negative 2, which is what we have there, divided by 3 factorial. P, a is p, then negative 1, negative 3, and negative q b cubed, because our b is negative q. Then we go ahead to simplify this. So again, according to laws of indices, when a number is raised to a negative power, it can be written as its reciprocal raised to a positive power. We're going to do the same there. We've got -1, -1, which is -2. So we've got p -2 there, and if we reciprocate it, it will change into a positive. And that's what I'm doing now. So we've got -1, -3, which will, when reciprocated, will be 3, p raised to the power 3. The same here, -1, -3, when reciprocated, we're going to have p raised to the power 4. Everything else, I've written it the way it is in this step. I'm going to simplify it in the next step. Okay, so in the next step, we'll simply remove 1 from there, because any number raised to power 1 is itself, so it will remain p here. This -1 and that positive will make this negative. Okay, we're going to have -1, -1 there, which will give us -2. -2 multiplied by -1 will simply give us a +2. That's where I'm getting that from. We've got -1 here. Here we've got -2. Here we've got -3. So -3 multiplied by -2 will give us +6. Multiplied by -1 will give us -6. Okay. Then in the next step, obviously that cannot be simplified any further, so I'll just leave it the way it is. But q raised to the power -1 is simply -q, and -q multiplied by that negative will become positive. That's what I've gotten that positive from. So it's simply going to have q over p squared. And if I raise -p squared to the power 2, it's the same as multiplying -q multiplied by -q, which will simply give me +q squared. That's where I've gotten that from. Why have 2 and 2 factorial disappeared? Because 2 factorial is 2, which will cancel out with that 2. And so I'll just remain with that. -6 divided by 3 factorial. 3 factorial is 6. So -6 divided by that will leave us with -1 here. And this one is going to give us -q cubed. So -1 and -q cubed will simply give us a +q squared. That's what we're going to have. Simple. Again, we see a simple pattern here. We've got q raised to the power 1, then 2, then 3. So we can guess what will come here. To be q raised to the power 4, then q raised to the power 5, and so on and so forth. We've got p raised to the power 1 here, then 2, then 3, then 4, and of course here we'll have 5, then 6, then 7, and so forth. Okay, remember in the previous video I said that when you're raising a number to a negative power, the series does not terminate. It progresses into infinity. So you've got to terminate the series at one point. And the best point to terminate the series is when you've written the first 3 terms. Or, if you love it, you can even include the 4th term. Please don't go ahead. You'd simply be wasting time to include the 5th term and the 6th term, and so on and so forth. So this is how we expand binomial expressions raised to a negative power. Here are a couple of examples. Okay, please expand these binomial expressions. Remember, just expand up to the 3rd term. Okay, if you've got problems, you can reference John Bird, 6th edition. Thank you.